Hey guys, welcome back to another Algebra 2A video. This time we're talking section 2.8. We're going to solve, well, it's called solving absolute value equations and inequalities. We're going to work on compound inequalities today, and in the next video we'll talk about absolute value stuff. So what we're talking about today, like I literally just said, is compound inequalities. Compound inequalities are inequalities where you've combined two or more different inequalities together. And you can combine them with two words. Either we've got or we have and. And here's the big difference between them. An inequality that uses or means that it's going to satisfy one or the other. It might satisfy both, but it doesn't have to. And in fact, in most cases, the two inequalities really don't work together. They just happen to be linked. So what I mean is this. Let's look at this example here. We have x plus 6 is less than 4. So we end up solving. We get x is less than negative 2. We have 2x is greater than or equal to 8. And when we solve that, we get x is greater than or equal to 4. There aren't any numbers that work for both of these, right? You're either less than negative 2 or you're greater than or equal to 4. You're not both. It's impossible. So that's what creates this or situation. It's either this or that. Can't be both. And these kind of situations, you're going to basically have two lines. You'll have this open circle here at negative 2 and the arrow pointing to the left. You'll have a closed circle here at 4 and you'll have your arrow pointing to the right. And that's going to be the case all the time. With or types of situations, your graphs are always going to look like this. You're always going to be pointing out in opposite directions. The second type, like I said, was an and inequality. In an and inequality, the numbers have to work for both. They have to. You have no choice. So if we solve this one, we get x is less than 3. And we solve this one, we get x is greater than or equal to negative 4. So if I were to actually, I'm going to rewrite this so I can show you what it really should be. Negative 4 is less than or equal to x, right? Because x is greater than or equal to negative 4, and x is less than 3. This is a classic compound inequality, and notice that x is in the middle. It's in between negative 4 and 3. So when we graph this, we get this kind of a situation here. You'll have, well, it's a closed circle because it's greater than or equal to negative 4. We have the open circle at 3, and we're going in between them like this. So for and, it's always going to be, you're always going to come together. And I'm trying to think of a way to show that visually. Basically, and is always going to be like this. They're going to come together. So you're going to have this bar here, like in this example. Or is always going to be the arrows pointing in opposite directions. Now how can you tell whether you get an and or an or? Ors are easy to tell. You're going to see the letter, you're going to see the words or. You're going to see or. There's no other way to represent that. And you might see the word and, or you might see a situation like we've got here, where you've got this expression in the middle and you've got to solve either side. So let's work out some of these and see what we get. Change up my color. We got x plus 3 is less than 2, or 1/2 x is greater than 1. So over here, I'm just going to subtract 3. So I get negative 1. To get rid of 1/2, I'm going to multiply by 2. So I get 2. Now, if this happened to be negative, I would have to switch my inequality, but it's not. So I get x is less than negative 1, or x is greater than 2. So less than negative 1, that means I got an open circle at negative 1. Greater than 2, I got an open circle at 2. It's an or. Greater than means I'm going this way. And less than negative 1 means I'm going this way. Now, with all of these, you're going to have to graph your answers. But it's just number line graphs. It's not a big deal. Let's look at number 2. Negative 6x is less than or equal to 18, and x plus 6 is less than 6. All right, so here I'm going to divide by negative 6. Divide by negative 6. Now, what do I get when I divide by negative 6? I get negative 3. And notice that my inequality gets flipped around. I'm reversing my inequality. So what was less than or equal to is now greater than or equal to. And then over here, subtract 6. And I get 0. So I'm going to be between 0 and negative 3. These are both or equal to's. So my boundaries are both going to be closed circles. Now, I'm less than 0, so I'm going this way. I'm greater than negative 3, so I'm going this way. So this is an and, so I have this bar situation. If I were to rewrite this as a true compound, it's going to look like this. And you'll have that x in the middle. Let's do a couple more. X minus 4 less than negative 7. That means I'm going to add 4. So x is less than negative 3. Negative 4x is less than or equal to negative 4. I'm going to divide by negative 4. So x is greater than or equal to negative 1. Again, I divided by a negative, so I had to reverse or flip my inequality around. Less than negative 3. I'm going this way. Going to the left. Greater than or equal to negative 1. I will have a solid circle. My arrow will be pointing to the right. Negative 3x less than or equal to 6. So x is going to be greater than or equal to negative 2. I'm going to divide by negative 3. X plus 2 is less than 5. I'm going to subtract 2. I get x is less than 3. All right, so greater than negative 2, closed circle, because it's greater than or equal to. Less than 3, open circle. And this is an and, so I'm coming together right here in the middle. Oh gosh, let's just do 2 more. Why not? This one's easy. I'm going to divide by 3. X is less than 4, and divide by negative 3. X is greater than negative 4. Greater than negative 4, less than positive 4. Key word there is and. I'm going to be in between. Oh, wow, this one here. All right, so I'm going to add 2. So I'll have 1/2 x is less than or equal to 2. So x is less than or equal to 4. Or, let's see, I'm going to subtract 2, so I'll get negative 1/2 x is less than or equal to negative 3. X is going to be greater than or equal to 6, because I'm going to multiply by negative 2. So let's see, less than 4, greater than or equal to 6. Why would they do that? It's not even on the, that is the dumbest. There's 6. I gotta make sure I did this right, because why would they, subtract 2, that's negative 3, multiply by negative 1/2, multiply by negative, yeah, I don't know, but that's definitely 6. So I got an arrow going this way, and I got a open circle, and an arrow going that way. Alright, so the second half of this talks about solving absolute values. We will get to that later. I just want to go down and see if there's anything in the other note packet that you need to know. So I'm scrolling. I hope this isn't taking too much of your time, but I'm going. Still going. It's mostly the same stuff, it looks like. Yep. Alright, so that's it for today. Make sure you smash that like button if you learned something, and we'll be back with another video covering absolute value stuff very soon. Alright. Get to learning, get to math, and get to doing all that stuff. See ya.